Hi guys, we are recording question number 9 from section 3.4. This was a request from someone, and if you guys have another problem you want solved, just let me know. Okay, so what is this question trying to ask? What is this question trying to teach you? Well, to recognize there can be a hidden chains rule. First, square roots can always be rewritten as a power fraction. So this is a simple example of just using x squared. First, you can see that there's sort of a hidden 2 that we don't write with the square root. So this can just be expressed as a fraction of 1 over 2. Now that 1 comes from the fact that there's a little hidden 1 that we never bothered to write for the x. And of course the 2 comes from in front, from the front of the square root. And so this can basically be x to the power 1/2. I'm explicitly writing the brackets because when you see brackets, you should always think, oh no, change rule is going to be necessary if there's anything involving your variable inside. We can see there's an x inside, which means, uh-oh, we're going to have to do the chain rule. So in our case, we have the square root of x5 plus 1. So all that I'm doing here is I'm basically putting it in brackets, and I'm taking it to the power of 1/2 using the same rule we did before. And so now we see there's stuff inside the bracket that involves your variable x, the 5x, and we can see there's stuff outside the bracket. So our inner function, the g of x, is just going to be 5x plus 1. On the outside, you basically have your stuff inside, and then you have the 1/2 power. So it's effectively chain rule, and we're going to use the exponent rule. Alright, so let's start taking our derivative, because we found the outside and the inside function. I like to use the phrase, the outside derived with the inside left alone, multiplied by the derivative of the inside. So first of all, what's the outside? The outside is the 1/2. So how do we take the derivative of something raised to the power 1/2? Well, the first step is we would basically, if we imagine x cubed, we would move the 3 in front, and then we would reduce the 3 by 1, right? So in this case, we're taking that 1/2 and we're moving it down in front, and then we're reducing the 1/2 by 1, and we're multiplying by the derivative of what's on the inside. We even do that with x squared, but the derivative of x is just 1. So our next step here is we simplify and clean it up a little bit. The derivative of 5x plus 1 is just 5. Nice and simple, nice and easy. That's what we're doing on the very end there. And all I've done is I've taken that minus 1 and I've changed it to a minus 2 over 2. So I've basically taken subtraction 1 and changed it into 2 over 2. You can think of it like a pizza. If I take a whole pizza and I cut into halves, 2 halves, right? It's still a whole pizza, regardless if it's a half. And if I were to cut into thirds, or fourths, or fifths, it doesn't really matter how many times I slice the pizza, it's still one full pizza. So in this case, I'm just choosing to slice it into 2 halves, only because we had a half over here. If this was a third, I'd probably slice into 3 pieces. If it was a fourth, I'd slice it into a fourth, right? So now, we can go 1/2 minus 2 over 2 is going to get you negative 1/2. And that multiplied by 5, I just moved that in front. So instead of 1/2, it's 5 halves. And that's all there is to this problem. There's nothing more than that. Alright, thanks guys. I hope you enjoyed that explanation. I have some other problems in this chapter. It should appear on a playlist. There's probably a recommended video way over there. And somewhere subscribe if you want to catch the new videos I'll be uploading. Have a good day guys, and thanks for viewing. Bye!